So in this short demo, we will look at another feature in Semantic-Kernel that lets you load prompt functions from the file system. And what we can see here is the blog that accompanies this demo. So what is a file-based prompt function? So what Semantic-Kernel lets you do is, well, is programmatically set up prompts as part of a coding scenario. What you can do is you can store the prompt definition and configuration in the file system. At the time of this recording, there are two ways to do it. You can create a text and JSON paired file combination, or you can use a single YAML file. And regardless of the option that you use, what happens is the content in each of the files is basically serialized to a particular prompt that's then sent over to the model. There are various reasons why you might choose to load prompt functions from the file system. I won't dive into all of them because they're all detailed in the blog that you can view. But the main reasons are for modularity, reusability within your organization. It will make managing your prompts a little bit more easy to maintain, and it will help increase the collaboration of, say for argument's sake, using shared prompts. The anatomy of a file-based prompt function is the same regardless of the options that you choose, in that each lets you define the prompt configuration settings, a name, a description, any input variables, and any other descriptions that are needed by Semantic-Kernel and the language model to help better determine how to process a particular prompt. All of these get processed by Semantic-Kernel, and in particular the planner component is used, and that lets the runtime and the SDK know when and how to use the specific prompt function. For the text file and JSON pairing, you need two files, and we can see an example here for filing a complaint. So the SK prompt text file for this particular use case could be something like the following. A little bit of a closer look, what we can see is that we give the AI a little bit of a persona in the first three sentences, and we say that, be friendly, be polite, be professional, express empathy for any inconvenience that was caused. The config.json file that would accompany this text file contains the type, description, any execution settings, and any input variables. And for filing a customer complaint, it may look like the following JSON file that we can see here. So what we can see is the execution settings and the input variable request. And we have a description there that says this is the user's complaint. You could opt to use the YAML variant of creating a file-based prompt function for the same use case. This is a single file, and you would have all of the content in this particular file, and that's what we can see an example of here. I personally think that this will become the best practice in the future. That's just my 2 cents, purely because of the portability that's available between importing and exporting these YAML files within Azure AI Studio. So that's enough of an overview of the blog. What we'll do is we will jump into Visual Studio and take a little bit of a closer look at this code in action. So here we are back in Visual Studio, and we've got a console application that we can see here. If you look over to the right hand side here, we can see in the folder structure we have a folder called prompts. Within there we have a folder called complaint and the two text files that we were talking about in the accompanying blog. If we open the prompt file, this particular prompt definition is handling a customer complaint. On line 5 we can see that we expect a parameter called customer name, and that's indicated by the braces and the $sign. Down at line 8 we can see we have another variable called request. Again, we use the same notation. We can open the configuration JSON file, and what we'll do is we'll drag this down here, and we've got the type. We're using a completions endpoint at the Open AI service. We have a description for this prompt definition, so we're saying it will handle the customer's complaint. Some other execution settings for the maximum number of tokens that can be used, and we set the temperature for the model. We tell it the GPT-4 model to use, again with the tokens and the temperature. Important part here is if we look at the input variables node down between lines 16 and 25, here is where we tell the model that it should expect two input variables called the customer name and the customer request. And we have also got the description for each, as well as setting the Boolean fields required to true. So we're saying that when we send over this request, along with the definition that we can see above, the model should expect the customer name and request. So both of those two files define the prompt and the configuration as to how the model at the OpenAI end should process it. So we'll close this down, or we'll put it up here, and we'll open the console application that accompanies both these files. So we're looking back in at the console application. Not a lot going on really, but at lines 24 and 25 we load the prompts from the folder. We, like some of the other examples, between lines 27 and 28 we create an instance of the chat completions service, and then we get into the nitty-gritty of the conversation. We ask the user what their name is at 30 and 31, and then down at lines 34 and 35 we ask the person what their particular request is. Now, it's at this point where this is a very simplistic example. What you would probably do in more capable application or production application is you would infer the person's intent from the input and then decide which prompt to use. But for the purposes of this example, we're just going to execute the complaint prompt regardless of the user input. And that's what we can see between lines 41 and 48. If we take a closer look at line 42, we can see where we tell Semantic-Kernel to use the complaint prompt function, and between lines 43 and 46 we pass in the input variables that were previously input by the user. What happens then is Semantic-Kernel will inject these as part of the process when the SK prompt file and the config.json file are pushed over to the OpenAI endpoint, and then we simply stream the response back from the LLM and OpenAI between lines 51 and 63. So we'll run this application, and what we'll see is we get prompted to supply a name, and then we are prompted to supply our particular request or complaint. So now we can see the request and my name has been processed by Semantic-Kernel. Semantic-Kernel has taken both the parameters, constructed the prompt along with the definition, and sent it to the OpenAI chat completions endpoint. And specifically, we can see from the assistant that it's addressed me by my name, and a little bit further down we can see that it has identified generally what the request is about, specifically a faulty DPF filter. And then we get the generative AI aspect and some various other sentences that let us know that the request is being dealt with, and we can see that the model has generated a little bit of empathy as well. So in this demo, we've seen how you can store prompt definitions and configurations on the file system. We've also seen how those can be loaded at runtime by Semantic-Kernel. And finally, we've seen how to inject parameters as part of a human interaction with Semantic-Kernel, bind those to the prompt definition, send them to the LLM, and then generate an appropriate response. You can find out more about this particular demo by reading the accompanying blog on jamiemaguire.net.